The random access procedure is defined as following. The UE receive a downlink data arrival indication via a paging message from the eNodeB, or the UE have a data in the buffer for uplink transmission. First, the UE sends a random access preamble, message 1, to the eNodeB via the physical random access channel, PRACH. The message 1 contain the RA-RNTI. The RA-RNTI associated with the PRACH in which the random access preamble is transmitted, is computed as RA-RNTI equals 1 plus TID plus 10 FID, where TID is the index of the first subframe of the specified PRACH, and FID is the index of the specified PRACH within that subframe. For FDD, FID is fixed as 0. Therefore, RA-RNTI is decided by the sending timing. It means that UE specifies RA-RNTI by the sending timing of PRACH preamble. The preamble is randomly chosen out of the maximum of 64 available preamble sequences in the cell. A collision occurs at the eNodeB when two or more UEs choose identical preamble sequences and send simultaneous requests. The UE wait the random access response for a period of time defined by Windows response, then resend a new random access preamble to the eNodeB. Or upon receiving a backoff time from the eNodeB to resend the preamble after a time specified by the eNodeB. Preamble transmission may also fail due to insufficient transmission power. If the preamble is correctly received, the eNodeB acknowledges it by sending a random access response message, message 2, to the UE within the response window. The message sent over the physical downlink control channel PDCCH is actually a pointer via RA-RNTI to the actual resource in the physical downlink shared channel PDSCH, where the random access response can be received. After processing the random access response message, the UE receive the C-RNTI and decode the timing advance command TA and the uplink RAN that contain the assigned resource block with the MCS that should be used to transmit the RRC connection request message, message 3, via the physical uplink shared channel PUSCH, using the resources granted by message 2 including the C-RNTI. The random access procedure ends with a successful reception of the RRC connection setup message, message 4, from eNodeB using C-RNTI received in message 3. The main bottleneck of the reviewed signaling procedure, especially when the number of UEs or requests is large, turns out to be the growing collision probability of the preamble. Besides, random access response delivery within the response window may also fail, because of limited PDCCH resources. And furthermore, there is also some probability of unsuccessful reception of message 3 and message 4. Clearly, all these events are leading to an increased network access delay. The last step in the random access procedure consists of a downlink message for contention resolution. From the second step, multiple UEs performing simultaneous random access attempts, using the same preamble sequence in the first step listen to the same response message in the second step, and therefore have the same temporary identifier. Hence, in the fourth step, each UE receiving the downlink message will compare the identity in the message with the identity transmitted in the third step. Only a UE which observes a match between the identity received in the fourth step and the identity transmitted as part of the third step will declare the random access procedure successful. The contention resolution message is transmitted on the PDSCH, using the temporary identity from the second step for addressing the UE on the Layer 1 and Layer 2 control channel. Since uplink synchronization has already been established, hybrid ARQ is applied to the downlink signaling in this step. UE with a match between the identity they transmitted in the third step and the message received in the fourth step will also transmit a hybrid ARQ acknowledgement in the uplink. UEs that do not find a match between the identity received in the fourth step and the respective identity transmitted as part of the third step are considered to have failed the random access procedure and need to restart the procedure from the first step. Obviously, no hybrid ARQ feedback is transmitted from these UEs. Furthermore, a UE that has not received the downlink message in Step 4 within a certain time from the transmission of the uplink message in Step 3, will declare the random access procedure as failed and need to restart from the first step.